Namaste and Shalom. My name is Joseph Abraham. I'm the Counsel for Trade and Economic Affairs at the Consulate in Bangalore, India. The title for this session is Israel Nano Ecosystem Connecting Academia and Industry. And we hope to show how the connection between academic and industry offers excellent opportunities for investment, R&D, and commercialization. Israel's academic and business and government leaders form a natural ecosystem for nanotech as a key platform for ensuring R&D and excellence in the sector. With world-class research institutions, academic institutions with advanced programs in nanoscience and nanotechnologies, large number of startups, venture capital investors, and government funding, Israel has established itself as a powerhouse both for basic and multidisciplinary scientific research. Our first presentation will be by the panelist, Ms. Alice Polaski-Segev, Managing Director from the Tel Aviv University Center for Nanoscience and Nanotechnology, a seasoned professional with 24 years of leadership at large global and multidisciplinary organizations specializing in semiconductors R&D and fabrication market, excellent in deriving business development processes, identifying, evaluating, negotiating, and managing engagements that grow company profit and support strategic objectives, focused on customers' values, understands the technical requirements, and work closely with the business unit to guide and of product offerings and business development, strong leadership, and multinational executives' engagement skills. I would like now to turn over to Ms. Alice Polaski-Segev. Thank you.
Thank you, Mr. Joseph. And also thanks to the IATI for allowing me to speak and present my organization here today. So as Mr. Joseph mentioned, the background started in Israel here back in 2007 when it was decided to establish the area of nanoscience as a national priority with the goal of creating research infrastructures at 6 universities, one of them the Tel Aviv University. And this is the basis for the nano industries. In Israel, the founding back then was a mechanism of triangle support, government, university, and some private donations. So this is the background. There are 6 different nano centers at each university here in Israel. And I'm going to share my presentation now. Okay. So I'm speaking from the Tel Aviv University. Let's start. All right. So science and technology at this nanometric scale are, of course, the front of today's research in the academia, especially when talking about life, exact sciences and engineering fields. And this discipline brings this brilliance of creating nanometric structures with the precision of atomic scale. And these applications are about to explore new phenomena and invent new systems that definitely cannot be achieved with conventional technologies. And such activity takes place at our Nano Center on a daily basis. This center is the largest one and the most veteran one in its field nationwide. It was established back in 2000, so before the Israeli national initiation was launched. And currently it serves as a community for broad research performed by about 120 researchers here in Tel Aviv campus, and of course their teams from four faculties: so engineering, exact sciences, life sciences, and medicine. Okay. Of course, it's multidisciplinary in its nature because it's integrating all those 4 faculties and several many fields. And just an example, we're dealing with nanophotonics, with biotechnology, quantum physics, nanomechanics, nanomaterial science, also in the fields of energy, ecology, sensors. So it's a variety of fields that we perform research. We have an all-inclusive solution. So from process development stage to and the adoption to the customer-specific device production through testing and characterization. And we engage with the collaborations with industrial sectors and the list of companies that we perform development, prototype production and characterization is very long and diverse. Our mission here is first of all, and the most important is to enable Tel Aviv University's researchers to have an access to the most advanced technologies. Furthermore, we promote multidisciplinary research activities here in the campus, and we also manage a central facility. We do support recruitment of researchers to the university. We have educational programs for young researchers and also for general public. And of course, collaborating with the Israeli industry and contributing to Israel's technology evolution. Definitely, I echo Mr. Joseph. Israel offers an excellent opportunity for investment, research, and commercialization in the nanotechnologies. At a glance, our research facility itself. So, as I mentioned, it's more than 2 decades facility. It enables advanced R&D and advanced technologies, both in fabrication and characterization. Our current facility has 2 clean rooms of about 300 square meters and 14 labs. And we are expecting to significantly expand and advance our facility with a new center, which I will mention in a minute. We have an equipment fleet of about 70 systems, process tools, fabrication tools, and several analytical and characterization tools. And of course, the staff of experts. Each individual is a professional in its field. We do provide to the community of the researchers a central facility. We provide their students training and hands-on practice. And we work roughly with 50 industrial companies. We provide them services in terms of the process development, feasibility studies, and also prototype productions. We are with the University of Tel Aviv, but we are an independent P&L organization, and we have a business model based on a service fee. We do have also collaborations with several universities worldwide. We provide fellowships. We have research calls yearly. And it's important to emphasize that our infrastructure is accessible to everyone. So not only the internal Tel Aviv researchers, but also all Israel academics and industry or companies. Our central location definitely gives us a competitive edge, as does our customer-centric approach, our technology expertise, and our commitment to timelines and product quality. I think Mr. Joseph mentioned that my background is from the industry, so I'm very much committed and linked to the industry, Israel industry needs. So this is one of our missions. And now let me mention the new Nano Center building. So there's a new building expected to launch in autumn 23. It was donated by Mr. Roman Abramovich, and it's going to be like an iconic building in the Middle East with 3 floors. On the ground floor, we're going to have an 800 square meter clean room area with the highest standard of the semiconductors. So it's really going to be exciting. Let me show you that it's an actual building being being built. Let me run this little clip here. I think it's really cute. So yeah, this is the building. Very exciting for us. Just a quick look on on the layout of the clean room. As I said, highest standard of the industry, 800 square meters. We expect huge researches and industrial collaborations in this new facility. I will explore a little bit more about the facility. So we integrate two disciplines, fabrication and characterizations. Each center has its own staff and systems. So the fabrication center called the Shaul Center for Nanocare System. It's basically clean room. Most of it is clean room, and it enables development of processes, of fabrication cycle from end to end. So we do mass design until packaging and testing. We have a large variety of technologies, lithography, all kinds of lithographies, depositions, film depositions, etching. We have some micro machining technologies, of course, high resolution, scanning electron microscopes, variety of testing, spectrophotometers, and the list goes on. While in the Wolfson Applied Materials Research Center, we have 5 state-of-the-art tools of material science research, so XRD, XPS, more electron microscope. We have TOF-SIMS, time-of-flight secondary ion mass spectrometer, and we have TEM and STEM. So these are the 2 centers integrated into the one nano center. This is our staff, our org chart, just a glance on it. So I have here, I don't think we have time for that. I didn't take time. So how much can someone give like a time management here? Okay, so I have a list of fabrication and characterization tools. Really, I don't think we have time for that. This presentation is of course available, but you can get a sense of what do I mean when I say fabrication. It's, imagine like a mini foundry clean room. Okay, this is the facility that we have. And same goes for the characterization. We have really cool and state-of-the-art new tools that we just purchased. So there's a cathode luminescence SCM coming up, and 2 TEM tools coming up, spherical aberration corrected analytical TEM systems, and also an advanced XRD tool coming up. I did prepare a few slides, examples of the researches here in Tel Aviv, researches that were done in our facility. So let me start with Professor Tal Dvir. He is actually right now acting as the academic director of the center for the past 2 years, and he's of course one of the nanotechnology researchers. His work focuses on integrating electronic elements in engineered tissues, like the cardiac tissues, and the idea is to monitor the heart's activity online using these nanoelectronic devices and measure the tissue's activity and even release medications with click on a button. So for example, imagine that that the patient is sitting at home and he's not feeling well. So the MD has the ability to release medicines and medications into his tissue upon receiving a message from the patient. And this is really a breakthrough research. By the way, this innovation led to establish a startup, Metroself, and many of our researchers go into the, let's say, commercialization of their research in startups. So one of them are Metroself by Professor Tal Dvir. Okay, Damper. Okay, one of the other breakthrough stuff that is going on in our center is targeted delivery drug or targeted delivery medicine. For example, Damper was one of the was the first to demonstrate systematic RNA delivery using a targeted nanocarrier. So those nanocarriers are fabricated in the Nano Center. More in different field from the electrical engineering field. So Professor Adi Aryeh is using thin membranes to correct lens distortion in microscopic electronics. So these thin membranes are done at the Nano Center using focused ion beam technology, for example. Professor Karl Ellenbogen is using multi-layered metasurfaces to create augmented reality glasses. Once again, these structures are manufactured at the Nano Center. I think I will skip some slides because I want to get to two more slides. Some examples for collaborating with the industry without revealing, of course, any IP or any mentioning any specific company. Just a few examples. So the printing industry, for example, we had a major challenge for one of the companies. They were in a search to produce micrometric size link heads in a matrix of cells. So each cell should contain a colored ink ready for printing, and we created such a device, and the activation mechanism was thermal. So we built a resistor that heats up and causes the liquid ink to spread within the cell. So this made the printing made it enabled like the ink getting out. Another project was with a camera manufacturer that was looking to reduce the size, the cost, and the energy consumed by the camera. It's very common, by the way. So we supplied the solution of a three-dimensional electronic packaging via fabrication. So it's like a through silicon via thing. So we built a structure on the camera that enabled direct access instead of the conventional wire-on-wire connections. There are many startups now that require to create biosensor prototypes. So we are building them a field effect transistor, which is limited by potential changes on the induced surface. And this we do it by linking the molecules that are sensible. And then they change the distribution of the semiconductors materials electrical charge, and as a result of it, the conductivity. We do work with the security industry here in Israel. For example, we created an alternative to the conventional anti-reflective coating, as these materials erode over time and under extreme conditions. So we developed a nanometric level surface treatment within our fabrication process to simulate the optic properties of the original coating materials. So this is just hint of the examples of our collaboration with the industry. I think I would like to complete with a takeaway slide. So this, our center in Tel Aviv is end-to-end technology facility. It's gonna open its new most advanced center within 1 year and a half, and we're going to have about 70 fabrication and characterization tools and a large expert of multidisciplinary staff. We are an independent organization, so we drive our businesses based on technology services and collaborative projects. And our mission is to enable the researchers here in the Tel Aviv University to carry their research, support the Israel industry and education for students and the industry workforce. So please take with you that Israel offers an excellent opportunity for investment, research, and commercialization. And we are welcome companies and academy from all over the world to collaborate with us and contact us. We have a very good website. You can find us on the web anytime, and you can keep in touch. I think I will conduct my speak for today.
Thank you, Alice. I think it would be good if we could have Doron come on board. Doron is the CEO of StoreDot. He brings vast experience in business and technology management to StoreDot. And prior to founding the company, he served as a senior director of SanDisk. Doron, over to you.
Thank you very much. We're going to talk about nanotechnology in Israel with an application for electric vehicles. So StoreDot is a startup that actually started at Tel Aviv University, and we have used much of the facilities of the Nano Center. But we're going to talk today about the company StoreDot and the market that we are going after, and how nanotechnology is actually servicing us in supporting this market, and then our product roadmap. So we are basically creating the next generation energy storage technologies in order to enable a sustainable future, meaning batteries that enable fast charging of the vehicle. So we care about the driver experience, and our aim is to provide a stress-free environment for charging and driving. So like you would use a standard vehicle, combustion engine, the same way of experience we will enable with the driving of an electric vehicle. So the challenge that we are trying to solve is what is called the range anxiety. Some people call it the charging anxiety, where people are worried that they won't have enough power in order to reach their destination. We focus on the battery technology, but we work with our partners on the design of the vehicle and the charging infrastructure. But what we provide with our nanotechnology capability is the ability to charge a battery inside the vehicle that would enable to take all the power that the charging station is providing, to take it in minutes as opposed to hours of charging as people are used to do. So our nanotechnology basically is used in order to optimize the miles per minute of charging. So let's say if you have 5 minutes, we would provide 100 miles plus of charging. And this is something that is considered really 50% better than the rest of the industry. So we are optimized for fast charging, but we also have a strategic roadmap to move from what we call XFC, which is the extreme fast charging, to also extreme energy density, the XED, which will have a frog leap in the ability to provide even more mileage using fast charging capabilities. So we actually brand the products 100 in X. So 100 in 5 is 100 miles in 5 minutes. 100 in 3 is our next generation for 2028, where we would enable 100 miles in 3 minutes. And then 100 in 2 is really, I think, the holy grail, that basically it's a full charge of the vehicle in let's say 5 minutes. So this is something that we only think would happen in about a decade. And this is what we call a post-lithium solution that would enable above 550 watt-hour per kilogram. So just about StoreDot, we started about 10 years ago, as I mentioned, Tel Aviv University. We've raised over 200 million to date. We have a multidisciplinary team of 120 people. 35 of them are PhDs in various areas of nanotechnology, material science, quantum physics, organic synthesis, and of course, a lot of material science in the nanotechnology space. We have about 100 patents, most of them are granted, and the investors is really a very powerful list of, from BP to Daimler, which is Mercedes, VinFast in Vietnam, Eve Energy in China, Samsung from Korea, TDK from Japan, and very, very soon we will announce an investor from India, maybe even this week or next week, so stay tuned for another big name on this list. So StoreDot have received over the years many awards. Last one was from Frost & Sullivan about the innovation of the nanotechnology and how it supports the commercialization of electric vehicles. Well, the value proposition we can summarize in the focus on the ability to fast charge a vehicle, taking a holistic approach of a battery as a system, using lithium-ion capabilities, but leveraging on it with organic materials and nanotechnology, and then the ability to scale up the manufacturing, such as with our joint venture with Eve Energy in China that is currently producing our samples. So if we look at the entire ecosystem, we look at the Venn diagram of the manufacturing side, which we put a lot of emphasis on with the EV OEMs and with the infrastructure providers, where StoreDot plays a pivotal role in taking this technology into the market. So the technology itself is focused on the ability to create new battery technology. You cannot achieve really fast charging with traditional batteries because they are not designed for fast charging. The resistance is too high and the materials are not nanomaterials, and they are unable to really take all this power in a short amount of time. So we cover a lot of areas in our IP to basically protect a technology that starts from the active materials and the binders. These are, the active materials is actually the nanomaterials. Let's say silicon in nanoscale is an active material that holds the lithium ions. We have a number of additives to the electrolyte and the electrodes that we are actually synthesizing. We do a very unique formation process. This is the first charge of the battery that determines how stable it will be over its life cycle. And then the design of the entire system of the vehicle and the design of the cell. So this is a very holistic approach to lithium-ion batteries, so that they would be able to extreme fast charge. In the battery, you have the anode, which is the negative side, and the cathode, which is the positive side. Both of these require, I would say, innovation in the material science, including the nanotechnology and the organic materials. Also, the electrolyte, which moves the ions back and forth from anode to cathode, requires some specific properties. As I mentioned, we designed the battery as a system, how it should work with the layered structures and the voltage management. The active materials themselves, which is the metalloids, like such as silicon, with its nanoscale capabilities, the organic compounds, the data science that overrides everything and makes sure that we are actually doing the right experiments of the ability to improve the performance over time, because this is the goal of research, is to keep improving the performance. So basically, this is a nanotechnology inspired by nature with organic chemistry, with the data science, and with the focus on the active materials. And the reason that we use silicon is because in a conventional graphite anode, you need 6 carbon atoms to hold 1 lithium atom. But with the silicon, it's actually reverse. In silicon, this is on the right, the silicon is this red circle here. 1 silicon atom can hold 4 lithium ions. So you basically get like a factor of 6 or 7 or 8, depending how you measure it, of the capability of the silicon. And you can see it here that in graphite, you get about 350 milliamp hour per gram of the active material, but with silicon, especially with its nanoscale, you can get 65 or 6700 of milliamp hour per gram. So this is a very strong motivation to move to nanotechnology and to silicon in order to improve the performance of the lithium-ion battery. But it comes with a lot of challenges that we need to mitigate. The silicon basically swells when the active material receives the lithium ions. So you can see here that every charge you get a bigger particle, and every discharge it comes back to be small. But this motion of inflating and deflating of the silicon creates fractures, loss of contact, and unstable layers. It's called the SEI layer that manages the contact to the foil, which is where the active material is being coated on. So we took all these strategies of the electrolyte design, the binder design, the composite materials with its doping and alloying and coating, and of course the nanotechnology of this material itself, with the structure of the particle and the critical size of each particle, and the shape, of course, and all the measurements of the nanotechnology. This is how we mitigate this problem of the swelling and instability of the silicon. So we have a very, I'd say, sophisticated lab in Israel that we've invested over 20 million here in Herzliya in Israel. And this also includes a pilot line here on the left that produces the batteries. We have a test facility for all the batteries that have been produced. And you can see here at the bottom, the center, a lot of data science work is being done on the results that are coming from the thousands of experiments that are running both here in Israel as well as in China. So our target spec for the extreme fast charge is energy of between 300 and 330 watt hour per kilogram, which is the state of the art. And we are providing over 1,000 cycles of fast charging, consecutive fast charging capabilities. We are currently producing electric vehicle size batteries. These are 305 by 100 millimeter. So these are pretty large cells of 30. And now we are actually starting to work on 50 amp hour cells that would charge in about 10 minutes, fully charged. So this is like, the real revolution here is the ability to charge in minutes as opposed to hours. So this is basically it. I hope, you'll be able to come and visit us in Israel, and stay tuned from the news from India in the coming week or so.
Dr. Doron, thank you so much for that really exciting presentation. Allow me to add that you got a PhD at MSc and a BSc from the Israel Institute of Technology. You've had extreme experience in so many different companies like SanDisk, M Systems. So extremely impressive, and we hope to see you. We hope to see you in India and with Indian companies too. I would like to say a few words about the IATA. I would like to thank them for allowing us to connect to the two Israeli companies, the Israeli company and the Tel Aviv University. IATI is Israel's umbrella organization for high-tech life sciences and advanced technologies. They provide solutions and support at all levels and integrate various sectors and resources of the industry. A thank you to Lian and Liat for assisting us. I would also like to thank the organizer of the India's flagship nanotech event, Bengaluru, India, for the opportunity to present Israel's nanotech industry. I hope that this will enable nanotech experts in India and in Israel, scientists, researchers, industry, and startups to meet and develop tomorrow's technology. So a thank you to the organizers, a thank you to the companies, and a thank you for the opportunity for having us.